Hello, I'm Troy Schouten, a freshman at Stanford. I'll be presenting my research project, Identifying Contributing Factors for Mapping Schistosomiasis Risk in a Changing Climate. It was completed with the help of my sponsor, Julia DeLeo. As the effects of climate change continue to become increasingly evident in our world, the proliferation of waterborne diseases is an indirect consequence that warrants serious consideration. One such disease is schistosomiasis, a waterborne parasitic disease that relies on intermediate host snails who release mature schistosomes, a kind of parasitic flatworm, which then penetrates humans and take residence in the blood vessels before eventually being excreted. Humans become infected by coming in contact with contaminated water. The disease is overwhelmingly found in impoverished areas where people rely on unclean water for drinking and sanitation. The chronic nature of the disease, caused by continuous re-exposure to the contaminated water, further enhances this cycle of poverty. It affects over 200 million people, leading to organ failure, cognitive impairment, and infertility. There are two central questions of this research. One is focusing on how temperatures due to climate change directly impact transmission dynamics between snail hosts and parasites. The second question focuses on how humans respond to climate change and do actions like dam building and migration, and how these might affect transmission rates. This particular project aims to identify which methodological factors should be used in order to most accurately assess the impact of climate change and other consequential environmental factors on schistosomiasis transmission in Brazil and Africa. The following factors identified were based on an extensive literature review of schistosomiasis, remote sensing, and modeling in PubMed, Web of Science, and Scopus. In order to project future transmission risk, geographical and environmental data must be collected by using remote sensing technology like satellites. And the use of remote sensing technology to predict climate change scenarios, one important factor for being able to predict schistosomiasis endemicity is the identification of appropriate spatial resolution. Remote sensing technologies can capture a variety of geographic and environmental features in 3 dimensions, including atmospheric variables and temperature at different depths within water bodies. The best climate change data have resolutions of between 100 kilometers squared and 150 kilometers squared. The local heterogeneity of schistosomiasis, which studies suggest occurs at less than 8 kilometers, then suggests that higher resolution models would be desirable to capture specific variability. However, increasing the resolution of a model by a factor of 2 means about 100 times as much computing power will be needed. This can be negated somewhat by the practice of various types of downscaling, which can be used to infer higher resolutions. Nevertheless, the use of higher resolution data from 70 to 100 kilometers squared in the first place allows for more accurate downscaling methods to be applied. As more climate change models incorporate higher resolution data, more higher resolution data becomes available, benefiting the climatology field at large. In addition to the above mentioned methods for collecting environmental data, many studies include supplementary information like field malacological data, which is snail counts, as well as human epidemiological data, which can be tested in the form of diagnostic tests. Epidemiological data concerning schistosomiasis prevalence has historically relied primarily on the Cato-Cots technique, in which human fecal matter is microscopically examined for schistosome eggs. However, the emergence of new rapid tests, particularly the point-of-care circulating cathodic antigen, or POC-CCA test, necessitates a reevaluation of diagnostic methods. The point-of-care test uses a lateral strip to test urine for antigens secreted by the schistosomes. It is calibrated using a minimum of 3 samples of urine with known antigen levels. Validations of the diagnostic have found that it is cheaper to use and more sensitive than the Cato-Cots technique in low to high endemicity settings, although its reliability in very low endemicity settings remains inconclusive. The increasing prevalence of these tests as indicators for schistosomiasis demonstrates the need to include verified data obtained by different diagnostic methods, ideally combining results from the new rapid test with the results from the established Cato-Cots method, which can be cross-examined. By employing these innovative methods for acquiring the data needed to project disease transmission, it is possible to produce increasingly accurate models for transmission risk. By focusing on the future with collaborating with officials and educating local communities of these risks, the negative effects of waterborne diseases like schistosomiasis can be decreased, which will improve the health and quality of individuals in endemic zones, as well as helping to end the cycle of poverty. Thank you.